On number 22, D, E, and EF are tangent to the circle G, and we need to find the length of EF. If two lines are tangent and meeting up at that point out there, E, they have to be the same length. So if those are congruent, then I can set the lengths 4x plus 23 equal to 10x minus 19. I'm going to solve for x, so I'm going to take away 4x from both sides. And I'm going to get 23 equals 6x. I'm going to add 19 to both sides, and I get 32 equals 6x. And then I'm going to divide both sides by 6, and I get that x is like 5.33333333. But they asked me for the length EF. So I know that EF is equal to 10x minus 19. I'm going to plug in 5.3 in there. And when I multiply 10 by 5.3, I get about 53.3 minus 19, which is about 34.3. My bad. There we go. Okay. So EF is 34.3. Obviously, if this is too fast, pause, work through it before I go through it. It's not meant to be learning directly in the same pace as the way I go through these videos. So please, please, please make sure that you're, slowing this down and rewatching it a couple times in order to get everything straightened out. For 23, we need to find the perimeter. So you might notice that we actually have 3 different tangent lines going on here. And according to the rule that we just used about them needing to be congruent, this length here is 12.2, so this also has to be 12.2. And if this one here is 5.9, then this one also has to be 5.9. So then I have to think, well, what's left over? 27.4 without 5.9. That means this little section here has to be 21.5. So that means this little section is the same length, and that one's also 21.5. Cool. So if, actually we don't even have to do that, because if we knew the whole thing over here was 27.4, we could have just known that this whole thing was 27.4. So anyway, whatever. Okay, so to do the whole entire perimeter, I'm going to add up the side lengths. So along from Q to R, I have 5.9 plus 12.2, and then I'm going to add in the top side, which is 27.4. No. I'm right. They are not the same. My bad. So this is not the same as this because it's not an isosceles triangle. Sorry. Okay. Going back to the bottom part, we have 21.5 plus 12.2. So we're going to add that all up, and 9, 18, 22, and when I add them all up, 1, 2, 3, 4, 5, 6, 7, 79.2 is what I'm getting for that one. Cool. Topic number 8, angles formed by intersecting chords, secants, and tangents. For questions 24 through 31, find each measure, assume the segments that appear to be tangent are. Coolio, I can do that. So angle AED is inside here, and the property for this tells me that this angle on the inside is going to be the average of these two angles here. So angle AED, let's just say that that's x degrees. X is going to be the average of them. So I'm going to add up 140 and 92. and divide that by 2. And that's 116, and so that's the angle inside there. DEC is this angle here, and so I know that those two have to be supplementary because it's a straight line. So if I take 116 away from 180, I get 64. So that's going to be the size of angle DEC. Now on this one, if this arc is 98, I need to know the measure of angle QST. That's going to be actually half of whatever 98 is. So think about it, you could think about it in two ways, I guess. This line splits this circle around the outside into two parts. And the circle around the outside takes up 360 degrees. And when I look at the angles here, that splits 180 degrees into two segments. So they have to be proportional. And so I know that this angle here out of 180 is the same proportion as 98 degrees out of 360. So x out of 180 is the same as 98 out of 360. Or another way I could look at it is just that that angle is going to be whatever 98 divided by 2 is. So I'm going to get 46? No. 49. There we go.